Anti-roll bars are one of the go-to tools when you're tuning chassis balance. Typically, if you're entering a corner and you're suffering from understeer, you would soften the front anti-roll bar or stiffen the rear. Conversely, if you were suffering from oversteer, you would tend to soften the rear anti-roll bar or stiffen the front. It's pretty common knowledge that coil springs are rated in terms of stiffness. The stiffness meaning how much force needs to be applied to compress a certain amount. An anti-roll bar is just another type of spring. When one wheel moves up and the other one tries to go down, the anti-roll bar is resisting the movement between them. In order to be able to predict the balance and handling of the car before we get to the track, we can use some simulation. In order to do simulation, we need to be able to characterize the anti-roll bar in the same way that we would with the suspension springs. Normally when you buy springs, they're pre-rated. Their rate, the pounds per inch or newtons per millimeter, is given to you when you buy the spring. Alternatively, you can test them in a spring rating machine. An anti-roll bar is a little bit different when it comes to its stiffness. When you buy an aftermarket anti-roll bar, the stiffness isn't given to you by the manufacturer. Typically, you only need the stiffness values of the anti-roll bar if you're going to do some simulation. In order to do some simulation on a car we're going to be taking to the track, I need to get some stiffness values from the anti-roll bars fitted to the car. I'm going to give you a walkthrough of how I'm going to rate these anti-roll bars that doesn't require any expensive equipment to do. Here I'm underneath the car. I'm looking at the rear suspension that has the anti-roll bar that I want to rate. So this is the right rear wheel. This is the lower control arm, the forward control arm. There's an upper control arm that's got 2 pin joints at the top here and a toe control arm. There is the damper, which has the spring removed from it at the moment. And back here we have the anti-roll bar. This bar runs along the back of the car and connects to the lower control arm here. This is totally symmetric across each side of the car. You can see here this link that attaches to the lower control arm here has some adjustment to allow you to equalize the link height side to side on the car to get rid of any preload when you do your corner weight setup. And we can see that on the end of the anti-roll bar, on this one, we have 3 options to connect the link. What's happening is the suspension moves up and down. If one side tries to go up and the other side isn't going up, so let's say in this case, the car is turning a right-hand corner, so the outside suspension is going to compress and the inside suspension, the left side, is going to go down. That means the anti-roll bar will get a twist or a torsion moment about it. This side's going to want to go up and the other side's going to want to go down. Looking at the back of the anti-roll bar, that means this is the section here where you're going to get the torsion happening with this side going up and the other side going down. The resistance that the anti-roll bar provides is a function of its stiffness and its material and how it's installed and also its shape. The stiffer the anti-roll bar is, the less differential deflection you'll get. That means when one wheel goes up, the other wheel will tend to go up with it as well if it's really stiff. This is one of the tools you're typically tuning when you're tuning chassis balance. Here we can see the point that the anti-roll bar is secured in the chassis. That is one of the points it is pivoting about. So if that's the pivot and this is the lever arm here, the further away the lower control arm is connected from the pivot, the more leverage you have on the bar. That means the bar has less mechanical advantage over the suspension. What that really means in practical terms, the bar is providing less stiffness to the suspension, so it's less resistance. That means that the further out you put this link, the softer the effect of the anti-roll bar will be on the suspension. If you were to put this link in the rear hole here, which is closer to the pivot, that means you'll get a higher stiffness rear anti-roll bar, and as you keep moving away, it'll get softer and softer. What I want to know for this simulation is how much resistance this exact bar is giving me in the car. So when I pull down on one side, how hard do I have to pull down to deflect it a certain amount? And I'll repeat that test for each one of these positions in each of the anti-roll bars we've got here in stock, so we know what we've got before we get to the track. One of the advantages of testing this in the car as opposed to doing it on a test bench is that we're including all of the added up stiffness of everything that the anti-roll bar is connected to. In an OEM car like this, where you've got a factory brace down here to hold the anti-roll bar, as well as having the polymer bushes that are holding the anti-roll bar, this means you will get a significant amount of deflection, not just from the torsion of the anti-roll bar, but also from a lack of installation stiffness. In a proper purpose-built motorsport application, all of these components holding the anti-roll bar would be much more solid. If any of these components that are bracing the anti-roll bar are moving, it makes the anti-roll bar a much less effective tuning tool. Here I'm looking at the other side of the car. This is the left rear corner. I've got some of the suspension components removed to give me access to the anti-roll bar. but this is how I'm going to measure the stiffness. I've got a weight gauge here hooked up to a large ratchet strap that's on an anchor, and I'm going to pull down on this end of the anti-roll bar and measure how far it moves and how much force I need to move it with in a few different increments. Because the suspension on the other side of the car is on the damper and that's controlling the droop travel, this side cannot move down any lower. So when I pull down on the other side of the car, this part of the anti-roll bar will essentially be locked. That means that the force I pull down with on this is only going into deflecting the anti-roll bar and nothing else significant on the car. When I do these measurements, I'll take them in a number of steps per position, and then I'll move the shackle down to the next position and then the next position and record the stiffness at each step. I'll be repeating this method for both the front and the back of the car for each anti-roll bar that we have for this car and for each position in each anti-roll bar. It's quite a large test matrix, but once we have that data, we can use that really effectively in the simulation to get some good idea on setup before we actually turn up to the track.
If you liked that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you subscribe. We're constantly releasing new videos, and if you like free stuff, we've got a great deal for you. Click the link in the description of this video to claim your free spot to our next live lesson.